In this lesson today, I'm going to show you how to solve an equation with fractions in it. But before we get into this equation that's on your screen, I want to do a refresher course in actually multiplying some fractions and collecting like terms. In the first example we have here, I'm asking you to multiply 12 times 3/4 m. Since there's no operation between the 12 and the bracket, it means 12 times. What we do is divide the numerator and denominator by 4, so we get 1 and then 3, and we multiply 3 times 3 times m, which gives us 9m. What I've done now is showing you how to take the arrow out, because it's not really part of the operation. The second example is written a little differently. It is 12 times, in bracket, 3m divided by 4, rather than 3/4 of m. But again, you just divide the numerator and denominator by 4, you get 3 times 3m, which gives you 9m again. I'm taking out the small arrow again because it's just for demonstration purposes. In these other examples, I want you to multiply these numbers 12 times -2/3. Now this is not 12 minus 2/3 because of the bracket. We divide 3 into the denominator in 2/3 and we get 1. We divide 3 into the 12 and we get 4. And then you multiply 4 times -2. This is not 4 subtract 2. And you get -8. In example B, you have -12 in front of the brackets times in brackets 2/3. So you divide the denominator 3 by 3, you get 1. You divide the number 12 by 3, you get 4. But don't forget the negative here. So what you end up with is -4 times 2, which again gives you -8. So 4 times -2 or -4 times 2 in both cases gives you -8. The third example here is slightly different. It's written as 12 times -2/3. So again, you divide the numerator and denominator by 3. You get 4. Now this is 4 times -2, so you end up with -8. And finally, I'm writing a fourth example, which is not very common, but you have 12, and then in brackets 2 divided by -3. You divide the denominator by 3, you get 1. You divide the numerator, the 12, by 3, you get 4. You multiply 4 times 2, which is 8, but then you'll notice there's a -1 in the denominator, so once again you end up with -8. What I tried to show you here is in all of these cases you have 12 times 2/3 and there is one negative, whether it's in front of the 2/3 as a fraction or the 12 or the 2 in the numerator or the 3 in the denominator, doesn't really matter. You have 12 times 2/3 with one negative somewhere in the calculation. So the 12 times 2/3 gives you 8, and then you put the negative in front. So in every case, you end up with -8 as your answer. Now I want to do a little refresher on collecting like terms when there are negatives involved. In example A, we have three numbers, 100 minus 48 plus 8, and you would normally just do 100 subtract 48, which is 52, plus 8, and that gives you 60. Another way of looking at this, however, is if you take the 100 and then you combine the -48 with 8. And when you take the -48 plus 8, you subtract the smaller quantity 8 from the larger quantity 48, which gives you 40, and you keep the negative from the 48. You have 100 minus 40, which is 60. If you go to example B, the first term is 4m, so you can't collect it with the -48 plus 8. Now you notice I've said -48. You could just as easily say minus 48, because it doesn't matter to the end result in math whether you subtract 48 or add -48. So here we have -48 plus 8, and just like we did in the last example, you end up with -40 or minus 40, however you want to say it. So the final simplification here is 4m minus 40. In example C, we have 4m plus -48 plus +8. You rewrite the 4m, and then you take the plus -48 plus +8, and again you get -40, so you have 4m plus -40, which is the same as 4m minus 40. In example D, I want to show you the difference if the 48 plus 8 are in brackets. The order of operations tell you you have to add the 48 plus 8, so you get 56 in the bracket, and the negative stays outside. So you end up with 4m minus 56 in brackets, which is 4m minus 56. To recap, in the first example, we have 100 minus 48 plus 8, which is the same as 100 minus 40. In the second one, 4m negative 48 plus 8, you end up with 4m minus 40, or 4m plus negative 48 plus positive 8, which gives you, again, 4m minus 40. But the final example, when it's in brackets, it's not the same as the previous three examples. Now I want to get back to the original equation that we were going to do and show you how all of this recap applies to it. So if we look at this equation, what we need to do is eliminate the fractions. And the easiest way to do that is to multiply every single term by the lowest common denominator. And in this case, the denominators are 4 and 3, so the lowest common denominator would be 12. So what we do is multiply every single term in this equation by 12. We get 12 times 3/4 m minus 12 times 2/3 equals 12 times 1/3 m minus 12 times 4. You'll notice here that I put the negative or minus signs in front of the 12 that I was multiplying by, which is the way that I prefer to do this. But I want to show you another way to write these, which you might prefer. So if we repeat the original equation, write it down. Now I'm going to keep the negative sign in front of the 2/3, and then on the right-hand side, keep the negative sign with the 4. So now when I multiply by 12, the first term doesn't change at all. But the second term, I have to write plus 12, and then in brackets, negative 2/3, which is a different way of writing it. And then 12 times 1/3 m, and then plus 12 again times negative 4. I have to put the plus 12 in here to separate it from the bracket before it. So if we go to the left equation, we divide the numerator and denominator by 4. So 4 into 12 goes 3 times. We get 3 times 3m, which is 9m. Divide the numerator and denominator here by 3, and we get negative 4 times 2, just like the refresher course that I was showing you. On the right-hand side, we divide the numerator and denominator by 3, and we get 4 times 1m, which is 4m. And finally, it's negative 12 times positive 4, or negative 48. You can also say minus 12 times 4 and minus 48. It's the same result. On the right-hand side, the first term, there's no change. But in the second term, divide the numerator and denominator by 3, and we get 4 times negative 2, which gives us negative 8. Remember, as in the refresher, this is not 4 minus 2. The 12 times 1/3 m doesn't change. And finally, we have positive 12 times negative 4, and once again, that gives us negative 48, or plus negative 48, which is another way of writing it, as we saw in the refresher course. And if we rewrite this on the right-hand side of this page, we get 9m minus 8 equals 4m minus 48, which you can see is an identical result to what we did on the left side of this page. Now if we want to eliminate the negative 8 from the left side of this equation, because I like to keep my variables on the left side, we have to add 8 to both sides of the equation. So we get 9m minus 8 plus 8 equals 4m minus 48 plus 8. On the left side, the 9m minus 8 plus 8 is 9m, and on the right side, 4m, you remember minus 48 plus 8 is minus 40, not minus 56. Now if I want to eliminate the 4m from the right side, I rewrite it, the equation, and leave a little bit of space. I put 9m minus 4m on the left, and on the right side I get 4m minus 4m minus 40. So now on the left side, 9m minus 4m is 5m, and on the right side, the 4m's minus 4m cancel, and we end up with minus 40. In order to get 1m, we have to divide both sides of this equation by the coefficient of 5m, which is 5. So we get 5m over 5 equals negative 40, or minus 40 over 5. So m equals negative 8. On the right side of this page, I'm going to solve the same equation, but I'm going to write it out a little differently just to show you that there's more than one way to do this using proper mathematical operations. I'm going to rewrite the equation 9m minus 8 equals 4m minus 48. I still want to eliminate the negative 8 from the left side of the equation, but now I'm going to write the plus 8 at the beginning of the equation. As soon as I do that, though, I have to write a plus in front of the 9m in order to separate it. Now I write plus 8 on the right side of the equation, so I've added 8 to both sides. On the left side, the first plus 8 and the minus 8 still give me 0, so I'm left with 9m. And on the right side, the 4m minus 48 plus 8 is 4m minus 40. Now I want to eliminate the 4m from the right side, so I put a negative 4m on each side of the equation. You'll notice here that in the last line I did not rewrite the equation like I normally do before I subtracted 4m from both sides. In my experience, this may save a few seconds, but in the long run, students tend to make more mistakes, and it's not worth the risk. Getting back to the equation, on the left side, negative 4m plus 9m is still 5m. It's just written in the reverse, but it doesn't make any difference to the result. On the right side, the first 4m and the last minus 4m give you 0, so you're left with negative 40. So now we have the equation 5m equals negative 40. Divide both sides by 5 as we did before, and we end up with 1m equals negative 8. So you can see that the solution is no different. I just wrote out the equation without leaving the spaces that I like to do. I've taken out all the red marks to show you what these solutions should look like when you're all done. You can see that all the equal signs are one above the other, and the solutions are presented in a very logical and sequential way which others can follow. Math is not just about getting the answer to a problem. It's about learning how to analyze a problem, applying your knowledge to solve the problem, and then writing the solution in a way that's easily understood by others, which is a very important skill to learn. I hope this was helpful. Thanks for watching.